Buenos días a todos. Voy a empezar compartiendo la pantalla aquí. Fijan. Hubiera podido hacer la presentación efectivamente en español, pero mi español no es súper aún para hacer una presentación en Machine Learning. Entonces empezaré, puedo responder algunas preguntas también en español, pero I will switch back to English now so that I'm able to convey everything that I want to say. Can you see my screen?
Yes.
Great. So, hello everyone, and thanks for being here today. I'm very happy to be officially open the floor for this conference, and also a big thanks for the organizing for bringing forward such an important topic in Panama and for the invitation for this presentation. My name is Filippo Mazza. I've been leading and developing machine learning projects for global company across Europe, as I've been introduced. I'll give a little bit more detail about myself properly in a moment. But let me start first by explaining the topic and then move from there soon forward. So, a machine learning manager that designs and implements big data solutions. I'm working currently in the private sector. I work from the lab to the production across Europe. I'm now in Hewlett-Packard. I work in the UI and supply chain info distribution team. Previously, I was in Huawei and the big data cybersecurity team. So I see also the Dojo community having an interest in that sector. I was working on that topics. But just a big disclaimer here today, I'm not representing any of my current or previous employer, and the information here is really my point to give some of personal opinion and also shared by the experts in the field about the current technologies. I gave here my contact. You can scan the code to get me to get my profile on LinkedIn. I love to get your feedback and also stay in touch for future projects or internships. So don't be shy to write me or add me there. That said, back to the main topic. So I was thinking to make a technical presentation at the beginning, but then I thought that given the current AI evolutions, it was really better to give a broader picture and give some important points behind technically, but not just technically. And the main message that I want to convey from this presentation is really here. Today, everyone can use AI, especially generative AI, ChatGPT, BART, and what's more for text, images, and so on. But the AI results that we get now with these models can be wrong, and getting useful results is not really trivial. Yes, you can get something, but it has some pitfalls. And I'm not talking about prompt engineering, so the science of getting these exact ways to form messages that goes into the model so to get the real results. What I want to already underline here is that what you see on top are just a few of the still many positive outcomes. Then when for fun, for example, I try to get images of lifestyle in Panama. As you can see, some are plausible, some less. For example, the first image, those buildings, I don't, to the best of my knowledge, they don't really exist in Panama. So, and to explain how this is happening, it's very hard. So, in order to underline how we must be careful when using such AI, I structured the presentation in this way. So there will be some part that are along the main understanding of generative AI and AI in general, like a big core concept behind the machine learning that drives this model, and also some intermediate concepts. But especially I want to strike on the severe pitfalls that are there that unfortunately need to be taken into account, in my opinion, not just to use these models, but also to improve them further from a machine learning point of view. But I also added, interleaving these serious topics, some more funny parts related to how the AI could see a futuristic view of Panama City in the wake of the AI revolution. So really to make it lighter, I wanted to use this main theme that could make simple examples out of it. And before you ask, no, I did not add in the model the recent evolution about the Minera situation, but that could be a nice add-on for the next steps. So, spoiler alert, before we move on, a quick side note. Yes, I've used AI to do some work. The ideas are from me, but I asked, and I couldn't stop making a presentation about AI using AI. So I tried to use, for example, here, ChatGPT with PowerPoint VBA code skeletons so that it could kickstart the slides, some design from Microsoft as well, and some content rewriting with large language models. All the images, so the majority of images I've tried with this presentation are really from GenAI for images, and I'll explain later on how. But really, the human value, still some parts with prompts, but especially bringing intermediate reasoning into the results. So for those of you that are new to it, a little bit, few more concepts about generative AI. So in general, this is the branch of AI that focuses on generating new content, being text, images, or code, for example, to create software, music, and so on. And it's using machine learning algorithms. It has a very broad spectrum of application and is also fine-tunable, so you can approach it to use it for healthcare, logistics, every field that you can actually use some reasoning behind. It's still a little bit tricky. We will see that later, but it can already give a lot of value there. AI image generators and large language models like ChatGPT, Bard, DALL-E, and so on are part of this branch, of this large branch. These are powerful AI models trained on vast amounts of text or image data to generate human-like responses. But I know that it's a little bit tricky to situate ourselves. I wanted to get a little bit of a broad spectrum here, as we're talking about a specific subset of AI, and there is many buzzwords. I feel obliged to show here the bigger picture. Me personally, I'm working on the full spectrum, but closer to the global data science and AI part. And I think that the best way to understand this new AI is to start with a top-down approach, starting with what is AI, and then going into really the specific way to implement it through machine learning. So, starting with this concept in mind, I wanted to give an important point about AI, which is whatever marketing can say, whatever what's written out there, general AI is not there yet. So Terminator is still far away, don't worry, and not just in my opinion. The experts agree on this fact. There is no real general AI yet. Large language models are really doomed to a shallow understanding that will never approximate the thinking that we see in humans. So the current technology is not there yet. And it's not me to say that, it's really the head of AI at Facebook, Yann LeCun, that I quoted there. And this general intelligence will represent a future phase where we encompass the understanding, the learning, transfer knowledge across domains, and really adaptability like human can do. So somehow going from the abstract thinking, getting the common sense, and also emotions understanding. So it's not just pattern recognition like machine learning. And current AI instead operates under much more narrow constraints. And it's really focused on machine learning in many cases. Just as to narrow down the concept, what I'm focusing on is really getting computers to act without being explicitly programmed. I really like this definition from Andrew Ng, but especially focusing on the input that they got from historical data or synthetic data or examples that we can provide, but really following those to learn, and we will say a little bit more about learning later, to get these models to provide you an input that can have diverse applications like recommender systems, autonomous vehicles, and more, using different learning types that could be supervised, unsupervised. But really, what it is a combination of algorithms with data, with powerful computing hardware that gives you the machine learning of today, and through specific models, the newer that now are fueling general AI, we can get the AI of today. Even though these algorithms, many of them were there in the past. And I'm really talking about mid 1950s and starting from there with the first one that really fueled the most important one to me, that is the foundation of the machine learning and the AI of today. So I could not mention Gen AI without touching the artificial neural networks and deep learning. This is a computational model that is really important to grasp in order to see how we can get real value, and also how we can maybe reduce the challenges in current AI. And the basic model consists of really interconnected artificial neurons that have connections with weights, and these weights connecting the neurons in the network are learned during the training and adjusted based on what is the likely answer to a problem that we're defining, and correcting it through errors, backpropagation, and more. So I will not go into the details here, but what's important to see is that given this basic concept, then it has been evolved into what is the deep learning of today, where we have multiple layers of neurons stacked one on top of the other with some modifications, recurrent neural networks, convolutional neural networks, but really a computational model that has many hidden layers that get usually raw input data, so that it's fed through the network, and learning like a brain would do, just getting examples, understanding the errors, and correcting it. And all of this model can get very, very, very complex, because if you can think about this example I'm putting here, if just one neuron has a few connections, if you propagate those for millions of neurons that you will need to get sometimes networks for typical problems, you will see that this number of parameters explodes very fast. And all of this doesn't consider then how to, I'm not considering yet the output in the equation, that there could be some further post-processing and more. So it's very hard to focus on specific parts of the inputs with networks that can go very, very deep. And I think that one of the elements that got really into the foundational components of modern generative AI is the attention mechanism that allowed these networks to selectively focus on the relevant parts of the inputs that somehow mimic what the human is doing. Like in the example that I took from the paper, so I put my references here at the bottom, you can see that in this example, the output on the right is connected to the input on the left. In this case, this is a neural network focused on text. So we have a sequence of words, and each word that needs to be predicted is somehow related to the previous words, or actually even in some kind of networks a little bit later on words, but really that this system allows you to understand what the network needs to focus on and get the right, so overcoming the limitation of previous methods that were using a fixed length of context around what we want. So it's really a way for the model to make a step further into how the human brain works with remembering and considering longer range of dependencies that like humans will do in this case a sentence, but the same will be if you consider, for example, videos, where we have some frames that are somehow related to what happened previously. And for a human, it's very simple, but translating this into machine learning, it can be very tricky. And this method has been improving performance in many tasks. So it was really context understanding that made these crucial steps towards. And yes, this is a key ingredient in what the now current AI uses as a foundational model, that is the transformers. And this, so I will not, again, I will not go into the details here. My point is really to get from AI to generative AI, showing the main ideas that brought us here, and then later on explain which parts could be very complex and create something very funny that we will see later. So, the models I explained so far in the deep learning can get very complex. For example, in these kind of models, we can get even multiple layers of attention that simultaneously attend the different parts of the input, like, again, like a human would do. And through studies, it has been also possible to improve these models and require even less training time than previous neural network architecture, without recurrence, without convolutional components, so much faster, and also able to, with the multi-attention, to capture different contextual relationships that are there in the inputs. So without further going on into the technical parts, the main point here is really to show the basic components of generative AI that relies on complex neural network that have many parts that can go wrong, and we're just considering the model, not just the not even the input data yet. So that said, now that we have the basics of this, it would be nice to, we said there is no general artificial intelligence, so it's really specific, but let's then see the limitations and also the potential pitfalls. And as I said, I like to keep presentations simple, and a funny way that I had in mind to strike how there is no general intelligence yet is to raise the bar. And as the generated images, like the ones before, were still plausible, let's go for something where reasoning is actually a must. And given the presentation in Panama, I'd say let's simulate the future of Panama under the impact of technology. So, keeping this theme light, here's the general process that I used, so that it's a little bit clearer how we can. And there will be no coding, no demo, unfortunately. But the idea is really skipping the details for the sake of focusing on the main topic. And so the idea is to have human getting initial seed for conversation with large language models, here, for example, ChatGPT, and leave the large language model, so this big text model, generative AI, get the input for another model that generates images, and then refine this understanding when a human can see an issue, and then repeat and go over some of these steps so that we can highlight some pitfalls. So without further ado, the main point is that given these powerful models and given that things can go wrong, let's find some use cases and see how these first attempts making some quick questions to the AI with some specific, without any specific prompt. So asking, how would you see the future evolution of Panama? And as you can imagine, the first attempts were, let's say, basic, nothing new. AI fails to capture Panama City essentials. As I shown before in the pictures, those could be from almost everywhere. And before you ask, no, it's not just prompt engineering. Also because if you really need a very well-crafted prompt, so a very well-crafted input for this model to understand what you want to do, maybe the model is not intelligent to start with. So let's make this careful process step by step and see what we get. So the first thing I tried was to ask, okay, given Panama City and given the advance of AI, tell me what could be the future evolution. And this already highlights the first pitfall. If we put this into the model, so the transformer give us a text sequence after it that is, Panama is set to experience a significant transformation in the upcoming decades. This could be very true, but we didn't need the AI to tell us that. I think that this is quite generic enough that everybody could have guessed somehow this. And even if we try to repeat the process of the model, maybe with different seeds, so the model can always give a little variation of answers in the outputs. If you do that, you will get something like the evolution will be heavily influenced by the advances in AI, reshaping various sectors from logistics to healthcare and what's more. This is still true, and we still probably didn't need a very advanced artificial intelligence to do that. How can we actually get some more reasoning and creativity in what we actually get? It's not easy, and this is already underlining the first pitfall of this model that is really a concern for the community today. These generative AI models are quite nice to produce sentences, but they do not really reason. So models are just behave like fantastic parrots that are programmed to output the words one after the other. And these concepts somehow are linked inside this massive deep learning memory network that has these concepts are linked because they are internal representations in how they are in this hyperspace of the model. And so just to quote again the AI expert from Facebook, he goes even a step further and say that these autoregressive linear large language models really suck, and they are doomed because they cannot model the concept like a human would do. And up to the point that today, additional systems are sometimes in place to check the reliability of the output. Like, for example, here in Bard from Google, they started to add some checks that you can request, also require to make the output valuable when you get an answer. So they start to underline the text, giving you resources that you can go and cross-validate the output with. So to be sure what you get is actually realistic. So do you still see my video? I see that it's glitching.
It's okay. We are seeing.
Great. Sorry. So one step further would be to ask why Panama is a smart city. And one part would be to ask with the prompt the intermediate steps where the answers already are still vague. As you can see here, the answers that you start to get just after, like for example, because it's central to the modern urban development and enhances the quality of services, doesn't really mean much. It's something that, yes, it's clear that it's valuable, but it's not just this part that could be important for this. And also, as a second attempt, asking which cities have been considered in the reasoning, it gives you some more insights, but still it's something true and meaningful, but considering the nuances is of what's feasible is really hard. And let me just share here with you another part that I got, which is this one. So as you can see, one element you can see in this image is that the model, when you start asking for representations of Panama City in this, let's say, simulation that the model has made, is not really showing the current landmarks and character, right? Last time I checked those, this bottom right part of the image didn't really exist in Panama. There's nothing as such. So it can quickly deviate from what is standard, trying to predict little twists from the current state, unless you drive the conversation with these models. So unless you go into the details, it's very hard to get something meaningful. But so how did we get to this is the main question. Especially, why do we see such deviations, which are still plausible somehow, but they do not really make sense given the actual state? And one thing to consider, so I couldn't make a presentation about AI talking about machine learning without, of course, considering that if you put garbage in the model, you get garbage out. But so this is very common, it's very known. The data during the learning process must be clean, otherwise the model will not perform well. So machine learning is not magical. There will be data errors that will drive you to wrong predictions and wrong learning. But this is even more important. I wanted to repeat this basic principle because this is even more important with these closed and huge models, because it's even harder to have a clear vision of the data. Not just because it's a large amount of data that needs a large cleaning and still have some errors, but it's even harder when you have data sourced online, where you have non-factual data, you can have ethical concerns, simply fake news. So it's a mix of everything. And like we saw in the picture before, you can get data that is unrelated to the main topic you're dealing with. So maybe that was trained on data that had some representation, like the landmarks that we saw, and was deviating towards other cities, not Panama. So another point to consider now that I'm talking about the data is really these models need a large amount of data to learn. And many times these models you can find online. Now, I'm not talking about ChatGPT or Bard because you can access them online, but even those that you can download and retrain partially have had an important pre-train. So pre-train means that large amounts of data that have been used from the model's creator have already been inputted, the model has learned, and you get the model as such that you can work with. And you can retrain and so on. This is good because you can already have a model that is powerful and kickstart from there, but you have no visibility on the data that has been used, especially if it's a private model or private data, sorry. So how can we be sure that we don't produce bias? The results is a concern. Some AI experts agree on the fact that there are several kinds of negative social impacts and could be concretely producing issues, if not harm, amplifying these biases, even discrimination. And even in other cases, without going into that direction, but going more into legal issues, what about copyright? How can we assure that what the model is presenting now is not just inspiration from something more than copying really what has been learned? So I think that this is something important. And now that the basic issues are now clear, we can play and tune with getting a little bit more interesting and usable outputs. And the main point here would be, we know what is the somehow reasonable given the current state, in this case of Panama City, and add this context to the inputs so that we can get a little bit more value into these outputs. So doing so, we can play with, like in the image that you can see here. So as you can see, now this vision that the model has about Panama has been tuned with a very simple immediate thing to do, getting the ChatGPT output, refining the context given the output that we had before, input it into a image model, so to get a picture. And we can see immediately that one element that could be maybe deviating our results into something more concrete is, okay, it could be more plausible already, but it's still too far in the future. It's so the model, thanks to this vision that we have now more clear, has been picking up on something that is really the far future. So one immediate thing to do would be to so as a second attempt, creating something more close, so changing the context of the model, not making it propagate its reasoning into the far future, but just getting a little bit closer thanks to a carefully crafted context. So now we're doing this with text, but we could imagine in the future doing this already into the weights of the model with machine learning, and getting something more realistic that it's now a little bit better, in my opinion. It still has some vision of the bigger cities behind, with a swarm of drones that can help the probably logistics of the city, but still keeping some residential area outside. And so I wasn't able to understand why AI really wants that road. Maybe it's helping the road congestions in Panama, which could be good, but we will not be able to really understand what is behind unless we go a little bit further. But anyway, finally, after many iterations, we can force the model to consider more the current state and realistic trends and get something like a sweet spot between the tests. So like the one that you see behind here in the background, this is one of the many possible outcomes for a remodeling of the city in many years ahead that the model suggests, given the context that we give about everything that we said, the possibilities of machine learning, the possibilities of AI, the possibilities of Panama today, the possibilities of the logistics, and what's more, into creating a little bit more a transformation of the seaside of Panama. And this is one of the images I got. I wanted to share this, but especially what I wanted to share is that after all this refinement, finally we can get something like more meaningful and more useful from a realistic reasoning point of view. So, for example, we're gonna get into more concrete views, like Panama will evolve into a smart city, having positive impact on the quality of life of people. Especially then now we can go into the details, getting, for example, AI suggests work, so smart city for traffic light patterns where we can optimize public transportation, or sensor to predict maintenance for public infrastructure, improving the efficiency. Or I can go even more into the details, but the main point here is that we start to get something which is not only more reasonable and plausible, but also more into the details, and that considers a little bit more reality that we couldn't at the beginning. But still, there is a missing part that it's a very important pitfall, in my opinion, for the AI, which is something that machine learning needs to consider. That is the explainability. So far, we got nice results, but what is the ability to understand really makes the difference. Which features in the input and in the context have been really driving this outcome and not another one? Why the large language models output something like this? There are some models that allow you to do this, some techniques that allow you the interpretation of the results, but it's more and more the complexity raises into the models, especially with neural networks and deep learning, the more we confront some black boxes that do not allow this. Just to make an understand this concept, on the picture here, for example, I show something from my previous works during my studies, where to get really the gist of the model and to understand which are the important features, we can have some metrics inside the model, so we can extract the intermediate results of these mathematical equations and get which are the drivers of one result more or another. In here like a bar chart, where we see really each piece of the input driving positively or negatively, in this case, the results of our outputs. And something like this is unfortunately much harder with higher complexity. And one of the points I wanted to close with before going into the last part of the presentation was really getting somehow my 2 cents on this important topic, which is this understanding of the model and reliability and, as I said, interpretability is even harder when you have technology that is working, so specific technology with specific data from specific vendors, which could make AI less open. Also in this topic, many experts agree that the concentration of expertise and also capitals, in terms of monetary capitals, could be one of the issues in AI today. If you think about, so these models like ChatGPT and more, they have been trained with a huge amount of computational power. Even though they are somehow relying on quantities of data that are today available almost for everyone online, because you can always get the data theoretically. Even if you were able to get all the data, you will still have to train a huge model that needs a mathematical optimization behind that takes hours and hours of processing units. You can see already some sources mention that just to retrain ChatGPT from scratch, so to get a model, it can cost a few $1,000,000. It's not a model you can train on your computer and have fun with that. So it's really just the train would be approximately $20 million cost if I got this ballpark number correctly, considering the current cost. Of course, there will be some economies of scale and so on, but we're not talking about something that every organization can do. So this is something that could be in the longer term as well an important problem. And why all this computational power is needed is that if it was already complex before to train a neural network with few parameters, okay, the advance of technology allowed us to make it cheaper and faster, but imagine when you have billions of parameters, when you have a loss function, that is the metric that you need to optimize for that quantifies how the model predictions match the actual results. So the training end-to-end is a function of millions of parameters. Here in the image, I'm just showing a bidimensional series of values where the gradient descent can get to a reasonable optimization for this model, so that you can get from raw data, you can get those parameters that I mentioned before. And this is needing also iterative refining, where multiple cycles needs to be done. If you imagine this into the high dimensionality of the models of today, it's a very complex mathematical issue that it cannot be tackled with simple hardware, therefore the higher costs. So, just to go into a little bit more the creativity side also, many of these parameters offers us, so the parameters of the model, not only allow for large memory and large capabilities of the model, but also a lot of opportunity for tuning them. So if we want to go more into the creativity, it could be funny to play with these models to make them, what we say, hallucinate and change the outputs so that the model is more creative at the expense of the reliability, however. So far we tried to get very reliable results and that were meaningful. What happens if, for example, instead we go the other way around? So we take the softmax at the end of the model, that is the component that gives you a probability across the potential results and picks the best at every step, and it plays a crucial role in the sampling procedure. So somehow it affects the randomness of the model. So if instead this time we raise this value and we try to get less reliable values, less reliable results, what will we get? So essentially, we can balance tuning this value, more randomness or not, and I could not resist using this with as we said, as we did so far, with a large language model through the image generation, but increasing this temperature and asking again what could be Panama in the future with some hallucinations from the model. And if you do that, you get very interesting results, absolutely crazy, but very interesting. So for example, if we take the large language models and we raise that parameter, we start to get Panama Canal as a stage, not just a waterway, where we can see AI having, so in the advances of the AI having created autonomous boats that dance a maritime ballet coordinated by AI, being able to load and unload their merchandise, making a spectacle for the world to see. Or we can go even more crazy with the AI proposing as a future advance robotic hummingbirds that we do not know exactly why, but they work in the environment and communicate with the plants, together with the buildings and the environment. We're living a delightful game of harmony. So you can get also a little bit less in value for these parameters. So to get a little bit more creative results, but not really realistic, still with, for example, buildings communicating among them, where they can create clouds generating shades for the hottest days of the summer. Or you can also get sidewalks like conveyor belts that answer the problem of the congestion of the traffic that the first models were just touching, but they were not really able to give a solution without going into trivial results. And the last one is my favorite, where we can see like an electrifying future for Panama, where at night the lights in the streets are not just normal lights to illuminate the streets, but also somehow connected to the mood of the people. I wasn't able to understand why from the context of the model, but I wanted to share it because it was too funny anyway. So without going too much into the details, I really want to conclude with this important part that is, okay, generative AI is definitely a powerful tool that can give you great results, but it's not a general AI. So you need to really use it carefully. You can get parrot-like messages, you can get hallucination. It's very tricky to balance, and especially there is no reasoning. That's still the value from the human and how you use this tool. So I think that without going into the technical details today, everybody can use these models, but very much careful is needed so to avoid the pitfalls. So I want to conclude with a positive ending, however, from exactly the large language models. So this evolution is nice. It has been invented like this. I think that the message that is giving the model, however, that it's a smart city, but also a masterpiece that can be created with AI. And now it's up to you to make it become real, and the communities that you have in Panama to bringing forward the machine learning and AI. So that was funny. That was mostly the possibilities that there are there. There's many. Happy to make it become real with all the touch points that we have in the conversation. And thanks for your attention.